Okay, hello everyone. We are Team 18 and we are presenting Wild Sight. My name is Ziad,
I'm
and
Alejandro.
so we'll start with the project description. So we are building a wireless drone that streams live video and is controlled over Wi-Fi. So we have a Tornado server that has the flight controller where you can control the drone. The drone will use a camera sensor to capture a live feed from the drone and will send it to the website for viewing. So you will be able to control the drone from the flight controller uh, and and able to see the images that the or like the video stream that the drone is sending to it. For flight stabilization, we will use an LSM sensor that integrates a gyroscope and accelerometer. It actually has a magnetometer as well, but we will not be using it for this project because we found out it's not having reliable data, especially indoors. So the sensor will send the data to the ESP32 using I squared C, which then the ESP32 will process the readings and adjust the drone flight using a PID algorithm. Um, and for like the stabilization basically allows for easier flight experience when you're flying the drone. Okay, so for our design process, again, we have the web interface where you can control the drone and able to see the images that's captured from the camera and then go to the ESP32 and then the ESP32 send it to the web interface. And then again, we have the IMU sensor that send the gyro and accelerometer data over I squared C, the PWM signals. And then the ESP32 process like the data coming from the IMU sensor, and then based on that, controlling the motors. The main thing we're doing with the processing, like when we mean like processing the IMU sensor, we basically finding the roll angle, which basically the tilting over the x-axis, the pitch angle, which the tilting over the y-axis, and then yawing, which is like basically rolling over the z-axis. And this is like a capture of the firmware we are building. Where we are right now, we are done with the web interface, especially that we will have a slight modification in the interface that we'll talk about it later. We're done with sending the camera data to the ESP32 and displaying it to the interface. And also getting the IMU sensor and being able to find the angles. What is left for us is this loop, the flight control loop, which basically after getting the data and using a Kalman filter to find the angles, it should be applying a PID controller to then output the PWM signals to the motor drivers. This we're not done with it yet, but everything else from the camera signals and WebSocket sending commands to the ESP32, these parts are basically done for our project.
So in terms of design changes, since last time, if you remember, we originally bought little brush motors that were driven by MOSFET drivers that we made a little PCB for. Uh, we're not doing that anymore because we found out those motors are too weak to actually lift off a drone. We tried a frame as light as about 7 grams and it still couldn't lift that at full power. So we got these new like little 1103 brushless motors that are being powered by a 2S battery that should be more than powerful enough to like lift off our drone. And of course, brushless motors can't be driven by just like a MOSFET because they have a lot to do with magnets and it's just really complicated. So you have to get some kind of special ESC for them. And for that, we got like a 4-in-1 ESC board, which basically takes like PWM signals from our ESP32 and drives the motors using a bunch of MOSFETs and like microcontroller chips, as you can see here. Um, in terms of the control for the drone, we originally had like a little, basically like arrow keypad that you would like press to like send a signal of like up, down, left, and right for the drone. But we found that in order to like make a more effective control system, what we're planning to do is have like a analog joystick instead that like sends like roll, pitch, and yaw data to our controller, and that will determine how much our drone actually like tilts and moves forward. And then, like Syed said before, we're not really using the magnetometer because of its inconsistent readings. So we're just only using the gyroscope and accelerometer of our IMU to calculate all of our pitch, roll, and yaw angles. In terms of something new that we learned, um, we knew of something called the C rating of a battery, which is like how much current it can give out in terms of its capacity. But something else that's like special about things like LiPo batteries and drone batteries is that they have like an S rating, which represents how many cells they have in series in them. So for example, like a 1S battery has only one cell, which is just 3.7 volts, while a 4S battery has four cells in series, which is about 14.8 volts. For our design, we got 2S batteries, which is what our motors are rated for, and they have a maximum capacity of 7.6 volts, but we should be able to run them at just 7.4. And then in terms of interviews, we talked to two people. Charlie Seifert, who's a person that was in this class last year, who also worked on a drone. He's currently working on his drone right now. And then Professor Freeman, who's a control systems professor here. Um, we basically asked Charlie like, a bunch of things about like component selection, and he gave us some good info like what size of batteries we should aim for and like what kind of motors. Uh, the motors that he used were somewhat weaker than ours because he used a much bigger battery. But since our drone is smaller, he told us to like aim for more powerful motors, which is why we chose like the 8500 kV motors. Uh, Charlie also told us about the 4-in-1 ESC he used, but he also like told us to make sure it takes PWM inputs because the mistake he made was that his did not, which means that he had to like program a different protocol to communicate to his ESC from his ESP32, called DShot, which is something we could implement in our project, but that's not really something we have time for at the moment. And then something else is just he told us that it's probably better to test our control code without propellers just to make sure we don't like harm ourselves or like make the drone like crash while we're still working with code that doesn't necessarily work. And then there was a Professor Freeman that we messaged. We just asked him about just implementing like a control system for our drone in general. And he just basically told us that like a PID controller for like yaw, pitch, and roll is just a good place to start and we can work off of that. And then he also like recommended us a paper to read called Quadcopter Dynamic Simulation and Control by Andrew Giviansky. Um, it's basically just like a paper that like, talks about like simulating a drone and like its control system using a PID loop. And it also has comments about like parameter tuning. One of the things it mentioned was like it was like extremum seeking that we can use to tune our PID parameters.
Okay, and the last thing is our questions for the class. So the first thing, again, like we will be using a joystick to control the drone movement through the WebSocket instead of using the buttons as we explained earlier. So just wanted to ask you guys, do you think like it's a good user experience or would something like a keyboard control or a physical controller be more effective than having a joystick? Uh, that just like on the web that sends data over WebSocket. The second question is, do you think it would be better if our camera was positioned above or below the drone? So just like for image reference in terms of the drone, like what you basically see on the web interface.
Mhm.
And yeah, that's it.
Yeah,
Thank you.
that's it. Thank you.